Hello students, let us continue with the topic that we have covered in the previous video. In the previous video, you have studied what is atmospheric refraction and you have studied why stars seem to be higher than they are actually. Okay, so let us in this video see why do stars twinkle. Okay, twinkling effect of stars. Let us see the explanation to this question. Now, again we'll consider the same diagram. We have earth here, we have atmosphere which is assumed to be made up of different layers having different densities. As we know that this layer which is closest to earth has maximum density and also maximum refractive index value. So when we consider these layers, the outer layer is always rarer compared to the inner layer. So when starlight enters into the atmosphere, it always enters into an optically denser medium and hence this continuous bending of starlight takes place. I hope you remember all these things. Now let us see this twinkling effect. Now if this is the actual position of star, so this is the light coming from star which is traveling in vacuum first, space first. Here it enters into the outermost layer. So the bending takes place towards a normal as it is entering from optically rarer into optically denser medium. So as it travels through the different layers of the atmosphere, it continuously bends towards and towards normal as it is always traveling from optically rarer into optically denser medium. And we have seen there, if there is an observer there, that is a light reaching there which appears to be coming from here. So this is the apparent position of star. But remember one thing more students, that these different layers, they are not having fixed physical conditions. Yes, their physical conditions are different, their densities are different, but still these physical conditions of each layer are also not fixed. Like temperature and pressure of each layer, it is varying continuously. There are variations, fluctuations. It means when this light enters into the atmosphere, the bending is not fixed. It keeps on changing little bit. So apparent position is not fixed because the light here, the ray, continuously there will be change in the bend of this line. So we can say that apparent position of the star is continuously changing, shifting by small amount. So we can say that when we look at the star, its apparent position is continuously changing. And because of this varying physical conditions of the different layers, also as the apparent position is continuously changing, the amount of light which enters into the observer's eyes, which is coming from the star, which is actually coming from this star, that is also continuously changing. When less light enters into the observer eye, the star appears to be fainter. When more light enters into the observer's eyes, it appears to be brighter. So this results in twinkling effect of stars. In reality, stars do not twinkle. This twinkling effect is only due to atmospheric refraction. Remember in this case, you should that the different layers, their physical conditions are varying. They are not fixed like temperature and pressure, because of which there is change in bending and hence there is change in amount of light entering into the observer eye coming from the star, which produces this twinkling effect. I hope answer to this question is clear to you, and you should always prefer to draw the diagram along with the explanation. Students, also one important thing, we have seen in the previous video that stars seems higher than they actually are. But remember, that is more when we look at the stars near the horizon. Okay, the effect is less here. The difference in actual and apparent position is lesser as we move towards this side. So when we look at the star which is overhead, then the rays are coming straight. If you look up at the star which is over your head, so starlight is entering straight into your eyes without any bending. It means no refraction takes place, and I hope you have the answer for that. Why? Because in this case the light is entering normally. It is a case of normal incidence. I is equal to 0 because this is the normal at all the points. This line is a normal. So there is no bending taking place. So actual and real position of the star will be same there. I hope it's clear. Now students, let us see why don't planets twinkle. We know that stars twinkle but planets do not twinkle. Why? Let us see the explanation. Now planets as compared to stars, when we say planets are extended sources of light. Extended sources means they are not point source, comparatively their size is bigger. It's not that they are bigger than stars, but it only is because they are closer to Earth than stars. So we can consider planets as extended sources of light and stars are, we know, point sources of light. So as planet is an extended source, we can consider it is a collection of large number of point sources of light. So when light from planet enters into the observer eyes, it keeps on refracting as in the case of stars, but total amount of light entering into the observer eye from different point sources here which are present in the planet, total amount of light remains almost fixed. There is no variation in the amount of light entering into the eye from the planet. Because see, if you consider one point of the planet, maybe amount of light from that point has reduced slightly, but at the same time maybe for the other point the amount of light has increased. So overall we can say that the total amount of light entering into the observer eye from the planet amount remains fixed. There is no variation, because it is an extended source which can be supposed to be made up of large number of point sources of light. So overall here the twinkling effect is nullified, okay, and we can consider that planets do not twinkle. This is the only reason for that planets are extended sources of light. Or in the words you can also say amount of light entering into the observer eye from the planet is much larger. So even if very small variation is there, it hardly matters. Overall we can say the average of amount of light entering into the observer eye is constant. There is no variation in it. Hence planets, they don't twinkle. Now, this is the last optical phenomena, advanced sunrise and delayed sunset, which is based on atmospheric refraction as per our NCERT syllabus. Now, let us see what is advanced sunrise and delayed sunset. Now, you have started before that stars seem higher than they actually are. This is all because of atmospheric refraction. So, same is the case with sun also. When we look at sun, it appears higher than actually it is when viewed near the horizon. Now let us try to understand this. Now when does actual sunrise takes place? You know that this is horizon. So when in the morning sun crosses this horizon and reaches here so that it should be visible to us, that is the actual sunrise when it takes place. But in reality what happens? In the morning, first when we look at the sun, when sun becomes visible to us, it is not its real position. It lies below the horizon, and due to atmospheric refraction, we see it above its actual position. It means actual sunrise has not taken place, but it is visible to us only due to atmospheric refraction. So that is called as apparent sunrise. That sun is not lying above the horizon, but it is visible to us. For us, sunrise has taken place, but actually sun has not crossed this horizon. It has not reached here. The time difference between the actual sunrise and apparent sunrise is of 2 minutes. Similarly, students, delayed sunset. Now in the evening, when sun crosses this horizon and goes down, when it crosses this horizon, we say sunset takes place. But when in the evening sun goes down, actual sunset takes place, but still sun is visible to us near the horizon here. Why? Again because of atmospheric refraction. So the actual sunset takes place, but for us sun is visible, so according to us sunset does not take place. So that is when we see the sunset, that is apparent sunset. And again here the time difference between the real sunset and delayed sunset is of 2 minutes. So we can say length of the day, that is time during which sun is visible to us, is increased by 4 minutes due to atmospheric refraction, due to advanced sunrise and delayed sunset. I hope this is clear to you. Now the last one example I can state here, but we are not going to discuss it in detail as it is given in NCERT, so you should know what it is. Flattening of the sun's disk during sunrise or sunset. You must have seen that when you look at the sun, when it rises or it sets, its disk, it appears to be like a flattened disk. Its size appears to be bigger. Okay, it does not look completely round. It appears to be like a flattened disk during sunrise or sunset. Again, that is because of atmospheric refraction only. But in that case, what happens? If this is a sun, we know that it is an extended source of light. It is quite closer compared to other stars. It is not a point source of light. And here we can say, from this, light coming from this part undergoes refraction. Similarly, light coming from this parts undergo refraction. And light from these two parts, in fact, light from every point on the sun undergoes refraction. But refraction is not same for all. There is unequal refraction taking place of the light coming from the different points of the sun. And this results in flattening of sun. So sun appears to be flattened during sunrise and sunset. But remember again, when sun is overhead, then it is not flattened, because at that time there is no refraction, and we know that is a case of normal incidence. I hope atmospheric refraction and all the optical phenomena which are based on atmospheric refraction, which we have covered in these two last video and this video, are clear to you. So we'll continue in the next video, students. Thank you.